Welcome to your online training module. In this unit, we take a closer look at the ecological changes that impact vector-borne diseases within the region. But before we begin, let's take a look at what is happening in Vectorlandia as they respond to an outbreak.
Vector control staff are warning communities about rising risks of a vector-borne disease outbreak. Rapid population growth has led to deforestation and poorly planned housing, creating ideal breeding grounds for vectors. The clearing of forests has also exposed persons to sylvatic vector species. Local streams are also drying earlier than expected, signaling ecological changes that may worsen disease transmission.
The spread of vector-borne diseases such as dengue, malaria, Leishman-I-Cis, and Chagas disease is closely linked to environmental conditions shaped by climate change, deforestation, and habitat loss. In this unit, we will examine how both climate change and human activities influence the emergence and intensity of vector-borne disease outbreaks. What is climate change, and how does it impact human health in the Americas? Climate change refers to long-term alterations in the Earth's climate, primarily driven by human activities. These changes often manifest as extreme weather events, including above-average rainfall, flooding, droughts, and rising sea levels. In tropical regions, excessive rainfall creates ideal conditions for vector breeding, leading to larger vector populations and an increased risk of vector-borne disease transmission. In regions with inadequate infrastructure, increased rainfall often leads to localized flooding and the formation of stagnant water sites. Conversely, during periods of drought, communities may store water in buckets, pans, and drums to meet their daily needs. In both scenarios, vectors such as mosquitoes exploit these water sources to lay their eggs, resulting in higher vector populations and an elevated risk of disease transmission. Climate change has also altered weather patterns, with tropical regions in the Americas experiencing increasingly prolonged and warmer periods. For vectors such as ticks and other arthropods, higher temperatures extend their active periods, providing more opportunities to feed, reproduce, and transmit diseases. Additionally, research indicates that pathogens develop more rapidly in warmer conditions, further increasing the risk of vector-borne disease transmission. In some areas, sea level rise is responsible to flooding of coastal areas and rivers. This disrupts sanitation efforts and can create pockets for new vector breeding sites where opportunistic vectors can now flourish in new areas. There have also been reports of shifts in climate zones where vectors move to higher altitudes due to changes in temperature making it suitable for their survivability. Climate change can also affect weather patterns such as El Niño, where it can lead to excessive rainfall in some areas and severe drought in others. This may lead to higher incidences of arboviral transmission and malaria in the region. Climate change has indirect effects as well. Some areas may become too cold or too hot, and as a result, lead to animal migration. Animals may migrate to more suitable environments, introducing new vectors and pathogens to new environments. As mentioned, climate change is the rise in global temperature caused by human activities, and in addition to climate change, direct human behavior can cause changes in the ecology and cause outbreaks in the region. Movement of livestock and animal products and international trade can move unwanted vectors and pathogens to susceptible communities. Human movement, particularly through tourism, plays a significant role in the spread of vector-borne diseases. When susceptible individuals travel to regions where these diseases are endemic, they risk returning home with infections that were not previously present in their communities. The vectors may also be transported by clinging to clothing or hidden within luggage. As demand for residential development grows, forested areas are frequently cleared to make way for housing. This expansion increases human exposure to sylvatic vectors and the diseases they transmit. A clear example is the phlebotomine sandfly, which can infect foresters and nearby residents with leishmaniasis. Deforestation not only destroys natural habitats, but also disrupts ecological balances by displacing predators that would otherwise regulate populations of wild animals serving as disease reservoirs, such as sloths and rodents. As these reservoir species increase in number, the likelihood of sylvatic disease transmission rises, elevating the risk of infection among individuals who work in forested environments, including rangers, foresters, and foragers. Communities that rely heavily on agriculture, cattle ranching, and livestock production may face heightened risks of vector-borne diseases affecting both animals and humans. Increased interaction between livestock and tick vectors raises the likelihood of transmission of diseases such as Rocky Mountain spotted fever among animal handlers. In Brazil, for example, an outbreak of Rocky Mountain spotted fever was linked to deforestation and capybara population. The rapid expansion of urban areas, coupled with the rise of unauthorized settlements, leads to inadequate infrastructure development. Limited access to clean water, insufficient drainage systems, and substandard housing conditions create an ideal environment for vector breeding sites and increases the risk of human exposure to vector-borne diseases. Mass migration, particularly during periods of political instability, can significantly influence the spread of vector-borne and infectious diseases into susceptible communities. Migrants often travel across multiple ecological zones, increasing their exposure to novel pathogens. Because many do not pass through formal border crossings or fear deportation, they may avoid seeking medical care until symptoms become severe. As a result, disease outbreaks can occur in new or informal settlements, where cases may go unrecognized by vector control programs and healthcare personnel, delaying timely response and containment efforts. Now let's listen to Dr. Yasmin Rubio Pellis as she highlights how human behaviors can influence vector-borne diseases within the region.
I got my first degree in biology from the Universidad Central de Venezuela, and then afterwards, I continued my studies in England. I got a PhD in medical entomology at the London School of Hygiene and Tropical Medicine. In 1985, I joined the Ministry of Health, where I was, since the beginning, I was involved in operational research for malaria, initially for malaria, and then some years later, I also included dengue control. So in the case of Aedes aegypti and albopictus, the spread of these species as well as the viruses they transmitted in Latin America is highly influenced for the aggravated situation in the storage of water in containers for human use due to unreliable or inexistent pipe water supply. Another major issue with the spread and intensity of transmission of arboviruses, let's say dengue, Zika, chikungunya, and Zika, is the inefficient trash collection service. So people tend to accumulate. I mean, I have seen that not only in Venezuela, I have seen that in Colombia, in Brazil, and the Caribbean island. I mean, people tend to accumulate all kind of trash in their backyards with containers that hold water and where you can find larvae and pupae of Aedes. Another major threat that I've seen in recent years is the expansion and the colonization of Aedes albopictus in remote forested areas inhabited by Amerindian populations where they would say the major issue for them was malaria, but now there is a major risk of the introduction and dengue and chiku and eventually Zika in those areas. Remember, over 75% of malaria cases in the region are reported by Brazil, Colombia, and Venezuela. Only Venezuela reported over 53% of cases. This increase is mainly due to the hot fossil in gold mining areas of southern Venezuela. It can be also associated with a decline in funding for the malaria program. The way I see it is that a very large investment in the health system as a whole, not only in the malaria control program, in the whole health system must be done, particularly in Venezuela, in order to revert the dramatic situation. So if the required actions are not taken, the intensity and the spread of malaria will continue within Venezuela and in other countries in the region.